Hello. In a few earlier videos, we looked at using some trig substitutions to make integration nice and easy. Sometimes you actually can use a trig substitution even if it's not immediately obvious. So remember that if we have an integral that looks like this, we have the integral of 1 over a squared plus x squared, where a is just some constant. We can use the trig substitution of x equals a tan theta. Now, sometimes you can maneuver a little bit. You can manipulate your integral so that it looks like this, even if it does not immediately look like that. So let's look at an example. So for example, let's say that we have x squared plus 6x plus 20. Now, this initially does not look like we could use our trig substitution of x equals a tan theta because we don't have something that looks like 1 over a squared plus x squared. However, what we can do is complete the square. So if you don't remember how to do that, I have a video on completing the square that you can watch. Let's talk about how we're going to work on this one. So we have x squared plus 6x plus 20, and we want to make this look like x plus something squared plus a squared, so that it looks like our denominator up there. Okay, so what we need to do is take this 6, divide it by 2, and put it right here. So we have x plus 3 squared. And then we're going to add on a squared, and we're going to set that all equal to x squared plus 6x plus 20. So let's expand x plus 3 squared. We get x squared plus 6x plus 9. And then we have our a squared. And that's all equal to x squared plus 6x plus 20. All right, so we can see don't need to worry about the x squareds, don't need to worry about the 6x. What this tells us is that 20 is equal to 9 minus a squared, or in other words, 9 plus a squared, or in other words, 11 is equal to a squared. In other words, put the 11 right here. And now we can say that x plus 3 quantity squared is equal to 11. X plus 3 quantity squared plus 11 is equal to our right-hand side right here, or left-hand side. Right and left, woof. Okay, so let's go ahead and rewrite that denominator then. So this is equal to 1 over x plus 3 squared plus 11. And now we can see that we have the form of our variable squared plus a squared. And if it's not obvious enough, let's go ahead and do a u substitution with u equals x plus 3, and then du is equal to dx. And we can then rewrite this as 1 over u squared plus 11 du. And now it's obvious that we have a equals the square root of 11, and we can say u equals a tan theta, which means that du is equal to the square root of 11 over cosine squared of theta d theta. Okay, let's go ahead and make all of these substitutions. So we see a u, we're going to sub in square root of 11 tan theta. So we've got 11 tan squared of theta plus 11. And then instead of du, we write square root of 11, 1 over cosine squared of theta d theta. At this point, I like to factor out the 11. So here in our denominator, we have 11s showing up in 2 places. Let's go ahead and factor out the 11. So our denominator becomes 11 times tan squared of theta plus 1. From here, I like to pull the constants out. So we have square root of 11 divided by 11 times 1 over tan squared of theta plus 1 times 1 over cosine squared of theta d theta. We have square root of 11 over 11. That simplifies to 1 over the square root of 11. Now let's look at what we're integrating. We have tan squared of theta here, but we know that tan is equal to sine over cosine. So let's rewrite tan squared as sine squared over cosine squared. And then the cosine squared stays there. Now we multiply these two fractions by each other. And so we get 1 over sine squared of theta over cosine squared of theta times cosine squared of theta. And then we have 1 times cosine squared of theta. Now we can see that cosine squared cancels with cosine squared, leaving just sine squared of theta plus cosine squared of theta. But we know that sine squared plus cosine squared is 1. So this whole denominator just simplifies down to 1. So this all leaves 1 over square root of 11, plain old d theta, or 1 over the square root of 11, theta plus some constant. Now, we are done with the integration, and we need to bring things back to being in terms of our original variable, x. But since we went from x to u to theta, first we need to go back to u, and then we can go back to x. So remember that x was equal to, u is equal to x plus 3. And u is equal to square root of 11 tan theta. So currently we're in terms of theta. So we need to go back to being in terms of u. So let's go ahead, bring it back to in terms of u. Right now we have a plain old theta. Let's solve for theta. So u over the square root of 11 equals tan theta, or in other words, theta is equal to arctan of u over the square root of 11. Okay, so we replace theta with arctan of u over the square root of 11. So now we have completed going from theta to u, and now we take the step to go from u back to x. U was equal to x plus 3, so wherever we see a u, we're going to sub in x plus 3. So we have 1 over the square root of 11, arctan of x plus 3 over the square root of 11 plus our constant. And now we can see we are back in terms of x, so we're done. This is our answer. Now remember, it's always a good idea to check your work when you're done. So let's go ahead and take the derivative of our answer and make sure that it's equal to our original integrand. So we need to check that it's equal to 1 over x squared plus 6x plus 20. Okay, so let's go ahead and take that derivative. So we have 1 over the square root of 11. Now we'll need to use the product rule here because we have arctan of x plus 3 over 11. So the derivative of arctan is 1 over, then whatever is in these pink parentheses here, squared plus 1. So we have x plus 3 squared over 11 squared square rooted plus 1. Now we need to take the derivative of what's within the pink parentheses, and we get 1 over the square root of 11. Okay, so we have a square root of 11 and a square root of 11. We can go ahead and combine these two square roots of 11, and that becomes 11. Similarly, here we have 11 squared and then also square rooted. So this is just 11 here. Now let's multiply these two fractions by each other, and we do that by multiplying the numerators and multiplying the denominators. So 1 times 1 is 1. And then in the denominator, we have x plus 3 squared over 11 times 11, and then we have plus 11. So this works out to be 1 over x plus 3 squared plus 11. And we're not quite here yet, or at least it's, good to do one more step. Let's go ahead and expand this square. So we have x squared plus 6x plus 9 plus 11. Combine the 9 and 11 to get 20. So now we're happy because we have confirmed that the derivative of our answer is indeed equal to our original integrand. All right, that is it for this problem. Hope that helps, and good luck on your math journeys.